right? I've shared some of the questions in terms of binary search. Am I? And I think in the end of that class, I have shared one question that is find peak element and all. Have I shared those questions with you? Say me yes or no. Yes, yes
Yes.
or no. Otherwise, I'll start with that problem if I haven't. I'm sharing that question. So, guys, I have shared one question in the chat box, and that is the first question in the pattern of binary search. So, I think we have discussed square root of x, which was following binary search. So, this would be the our with I think this would be our second question in terms of binary search. It's a standard problem in terms of modified binary search and violation in binary search. Fine. So, take 2 minutes and read this question, and any of you will unmute yourself and tell me what we have to do exactly. Then I'll tell you why we are using binary search here and what sort of things I have noticed in this question so that I have decided that I'll have to use binary search. So take 2 minutes and read this question. All right. Swapnil, can you just unmute yourself and tell me what we have to do exactly? Just explain me the description part of this question. Swapnil, Shrutika, anyone who is done with the description part of this question, please unmute yourself and tell me what we have to do. Like what's been written in that question? That's it. Anyone? Yeah. Thank you. Mhm. Mm-hmm. Neighbor means left and right, both neighbors. Okay, so okay, fine. So the second question, Swapnil, why we are using binary search in this question? Why this comes under binary search? The initial condition for binary search is that the array should be sorted, but the input which has been given to you, is it sorted? Then why I'm using binary search? Okay, fine. Thank you, Swapnil. Anyone else? Mahesh Bhai, Shrutika, Akash, anyone else who want to explain with the question? Okay, fine. So let's start with the description part, then the test cases, then why binary search is being used in this question. Fine. So to apply binary search, there would be two conditions which should be there, but it's not like that. If that condition will not be there, I cannot use binary search. Fine. So I have an array, and the initial condition is array should be sorted. And the second condition is the time complexity which you have to the time complexity which you have to use in any particular approach. And if the time complexity is big O of log n and you have to perform some sort of searching in that, you will gonna use binary search, because binary search is the only algorithm in terms of searching which will take you in big O of log n time complexity. Sir, how would I get to know this thing that I have to use binary search in this question? Let's start. A peak element is an element that is strictly greater than its neighbors. That means there is some sort of comparison between a greater element and a lesser element. That means there would be a case which would be followed. There would be some sort of arrangement, some sort of sorting things inside of that. Like two is greater than one and less than three. That means there is some sort of arrangement, some sorted arrangements. From there, I got a hint of 5% that I would gonna use binary search in this question. Second hint, given a zero index integer array nums, find a peak element and return it its index. Return its index. That means I have to perform searching in this question. It will ask me about a target element, and I'll have to return the index of that element. That means I'll have to perform some sort of searching. Second hint, I'll have to perform searching. If the array contains multiple peaks, return the index of any of the peaks. You can imagine that nums of minus 1 and nums of n is equals to minus infinity. That means to the extreme left of my array is it's minus infinity, and to the extreme right of my array it's minus infinity. That means every other element will be greater than my edge numbers. That means my 1 and my this one will always be greater than to its of right, to its of left. Third, the biggest hint which will allow me to think about the solution, which will go in log n. You must write an algorithm that runs in big O of log n time. And I'll have to perform searching, and there is some sort of arrangement in that. So I'll gonna use binary search in this question. So guys, please give me a thumbs up if I'm clear why I'm going with binary search in this question. Ritvik, can you come again? I can't able to hear you. Uh, yeah, sure. From the beginning. Okay, okay. So the thing is, in the first part, if you'll notice, it's been written as element it that is strictly greater than its neighbor. That means there is some sort of arrangement. There is some sort of shorting things it will be there in between the conditions. So I got a hint of 5% that man, there is a shorting condition in between. Can I use binary search here? So I'm not sure till now. Then a zero index integer array nums find a peak element and return its index if the array contains multiple peaks. Find return the index of any of the peaks. So I'll have to return the index. That means I'll have to perform searching in that index of any value. Then the third and the most important thing which allow me to think about a solution for binary search is you must write an algorithm that runs in Vigo of log n time. That's it. So I'll be using binary search in this question. Am I clear, Ritvik? Yeah, yeah. Now, let's take this particular test case and discuss what is a peak element. So I have 1, 2, 3, 1. I have a nums array 1, 2, 3, 1. So we have to find any of the peak element. So in the question itself, it's been written there. You can return any of the peak element because your array contains more than one peak element. So what is a peak point? So let's say this is a mountain and this is the peak point of my mountain, which is 100 meters from sea level. Fine. So why this particular distance is a peak point? Why this point is being called as a peak point? Because with respect to that point, every other hills which are there to the left and to the right of that hill will be having their height less than this particular point. So a peak simply means a peak point simply means to the left of it, things should be smaller, and to the right of it, things should be smaller. That's it. So we'll have to find an element in this array which will be greater than its left element and greater than its right element. So in the case of 1, in the question itself, it's been given that everything to the left of 1 will be minus infinity, and everything to the left of this one is minus infinity. That means this one will always be greater than to the left of and to the right of. So 1 is my 1 greater than 2? Is my 1 greater than 2? No, it's not. That means this 1 cannot be my peak element. Then I have 2. Is my 2 less than 1? Yes, it is. Is my 2 Sorry, is my 2 greater than 1? Yes, it is. Is my 2 greater than 3? No, it's not. So 2 cannot be my peak element. Then I have 3. Yes. 3 is greater than 2 and 3 is greater than 1. I found my peak element and the index of my peak element is 0, 1, 2. So 2 is my answer. But what about the pattern? So this question comes under modified binary search, second, violation in binary search. So what's modified binary search? Modified binary search, I think by the name itself, you can identify this thing. Modification in the algorithm of binary search to solve any problem is called as modified binary search approach. Fine. So I won't be following the exact algorithm of binary search, but I will be taking some glimpse of binary search. Fine. So in binary search, what we have to do, there is a low pointer, there is a high pointer, there is a mid pointer, and in terms of that, either we move in the left part of our array or we move in the right part of our array. So we'll be doing this thing. So while writing the approach for binary search, you will be always thinking about three conditions. The first, what will be my mid? Second, when I have to go in the left part of my array or when I have to go in the right part of my array. And third, what I have to return as an answer. Second, this question comes in violation in binary search. That means the place where the algorithm of your binary search fails, you will be getting your answer at that moment. So this question comes under two patterns. The first pattern is modified binary search. That means you will be applying some sort of modification in the algorithm of binary search. Second, the moment when the algorithm of binary search fails, you'll be getting your answer. Fine. Now see here. This time, what you have to do, you will be taking two pointers and let me have one of the test cases. Let me have this 1213564. There will be a low pointer which will be at the zeroth index. There will be a high pointer which will be at the last index of my array, that is 0, 1, 2, 3, 4, 5, 6. So there will be a while loop, and in that while loop, what I'll be doing, I'll be writing a condition that my low should be always less than high. I don't want that at any particular point of time my low is greater than high. That means violation simply means the moment when this condition gets failed, that means your low is greater than high, you will be getting your answer. So for the first time, what I'll do, I'll calculate my middle value. 0 plus 6 by 2, and that will give me 3. So the first middle value which you got is 3. So let's be at index number 3. 0, 1, 2, 3. And that is 3. Now what you have to do, you have to check is the element which is at the middle index, is it greater than your mid plus 1 or it is less than your mid plus 1. So what is the scenario for that? If my 3 is greater than 5, that means my 3 can be one of the peak element. And if my 3 is less than 5, that means 5 can be one of the peak element. Because if my 3 is greater than 5, the rightmost condition for a peak element is true. Now we have to check for the leftmost condition. And if my 3 is less than 5, that means 5 can be the peak element and the left condition is true, that is 3 is less than 5. So I'll have to move in the right part of my array. Guys, give me a thumbs up if I'm clear with this. How I'm moving in left and right part of my array. I'm repeating once again. Be at the middle element of your array. Compare it with the next one. If middle is greater than mid plus 1, that means one of the condition for peak element is true. M- This element is greater than to the element to the right of it. Now we have to check for the left element. And if my mid is less than mid plus 1, that means this mid plus 1 can be my peak element because something to the left of it is smaller. So we have to go in the right part of our array. And you'll keep moving in this way. And while moving, this whole loop will gonna break. And the place where your low pointer would be there, that is your answer. Let's start. So to move in the right part of your array, low will be equals to mid plus 1, and this time you have to include your mid also, because mid can also be your answer. So in that case, high will not be mid this time. High will not be mid minus 1 this time. High will be mid, because the current mid which you are on, it can also be the part of one of the condition of your peak element. Either it would be the left or it would be the right part of your peak element. That's it. So to move in the right, update your low with mid plus 1, and to move in the left, update your high with mid. And the moment this loop gets break, your low pointer is your answer. Let's start. I have 1 2 1 3 5 6 4. My low is 0, my high is 6, my first mid value is 3. At index number 3, 0 1 2 3, I'm having 3, and mid is less than mid plus 1. That means 3 is less than 5. That means 5 can be a peak element because something to the left of it is less than that. So I'll have to move in the right part of my array. So to move in the right part of my array, low will be equals to mid plus 1. So my current mid is 3, low will be equals to 3 plus 1, and that becomes 4. And high is 6 still. In the next iteration, my next mid will be equals to 4 plus 6 by 2, and that means 5. 0 1 2 3 4 5. I have 6. 6 means my mid is greater than mid plus 1. That means 6 is greater than 4. That means I'll have to go in the left part of my array to check the leftmost condition. And to move in the left, my high will be equals to mid. So my current mid is 5, my high is 5. So till now, my low is 4 and my high is 5. The next mid value will be 4 plus 5 by 2, that is 4. 0 1 2 3 4. I have this 5. Mid is less than mid plus 1. That means this can be my answer. All I have to do to check for the rightmost condition, and to move in the right part of my array, low will be equals to mid plus 1, that is 4 plus 1, that is 5. And if you'll notice one thing, low is also 5 and high is also 5, and this is the violation of the condition of while loop, because my low should always be less than high. It cannot be equals to high or greater than high. But this loop will gets break, and the moment where your low pointer is, that's your answer. See, 0 1 2 3 4 5, and 6 is the peak element. Or see, low is 5, low pointer is at 5, and the element which is at the index number 5, 0 1 2 3 4 5, that is 6, and this is the element which is your peak element. So you will be returning low pointer as your answer. Give me a thumbs up if I'm clear with this, or are we on the same page? Give me a thumbs up. Yeah, Shreyas. Mm-hmm. Can you please repeat that? Mm-hmm. 4. 3 5 6 4. Low pointer will be initially at 0, and high pointer will be at 0 1 2 3 4 5 6. So according to me, this 6 is my answer. This 6 can be my answer, and this 7 can also be my answer. So in the question itself, it's been given that the array can have more than one peak element. So at the time of the iteration, the element which you have got For the first time, return that element. That's it. So the element which you found, just return that if it is a peak element. Fine. Yeah, sure. Low is equals to 0, high is equals to 6, and mid is equals to 3. Fine. So 0, 1, 2, 3. At index number 3, I'm having 5. And for this particular condition, my mid is less than mid plus 1. Right? That means my mid plus 1 can be one of the peak element. So if it can be one of the peak elements, so left part is true. Let's move in the right part of my array. So to move in the right part of my array, my low will be equals to mid plus 1. So my current mid is 3 and my next low will become 4 and my high is still 6. Fine. Let's calculate the next mid. The next mid value will be 6 plus 4 by 2 and that is 5. Fine. So the next mid value is 5. 0, 1, 2, 3, 4, 5. That is index number 6. Fine. Index number 6 is greater than 4. That means one of the condition is true and let's move in the left part of my array. And to move in the left part of my array, I'll be doing high is equals to mid. My current mid is 5 and my lower till now is 4. The next mid value will be 4 plus 5 by 2 that is 4. 0, 1, 2, 3, 4, 5. 5 is less than 6. That means left condition is true. Move in the right. To move in the right, low will be equals to mid plus 1 that is 5. Low is also 5, high is also 5. The condition gets break and the moment when my where my low pointer is, it's my answer. 0, 1, 2, 3, 4, 5. That's it. 6 is my answer. Shreyas, am I clear? The condition, oh, okay. The condition is replace this 6 with any of the number. You will get 7. In these type of questions, the answer will not be specifically for any particular element. There would be a property. If that element follows that property, you'll have to return that element. In these set of questions which are under modified binary search and Boolean in binary search, you will always be returning that element which follows any particular property. Shreyas, am I clear? You cannot return directly 7 as your answer. You can simply return in a case where just replace this 6 with 1 or 2. You'll get your answer. Mhm. You can do that. But now what you are doing, you are checking for the previous one, right? So the cases will be reversed, but the whole thing would be same. Fine. So what you are doing, you are tending towards the left part of your array. I'm not doing that. I'm just comparing the right element and I'm deciding where I have to move. Fine. Am I clear? Yeah. So it's 9:40. Take 3 to 4 minutes and try to write the code by yourself. Low will be updated with mid plus 1. High will be updated with mid. And every time you have to check this thing, is your mid is less than mid plus 1 or your mid is greater than mid plus 1. And at last, when the whole loop gets break, return the low point. Take 4 to 5 minutes and try to write the solution by yourself. Then I'm gonna write the code for you. Mhm. Okay, so low less than or equals to high will be used in that particular case where you won't be needing the middle value every time. Fine. So if you have written the normal approach of square root of x, so if you'll notice one thing, we were not including middle value every time. Fine. For the first time, I was checking this condition that mid into mid should be equals to target. If it is, return that mid. But in this particular question, if you dry run this question, so mid is also one of the part of your answer every time, whether you are in the first condition or in the second condition. See, it is always the left part or the right part of your peak element. Are you getting my point, Shreyas? So for this reason, I'm not including mid. Yeah, yeah. Try to dry run it. I have written the code. I have written the pseudo code for you. Take any input value and dry run it. Everyone. Swapnil, Shreyash, anyone? Ritvik, anyone who's done with the solution? Arnav, Ayush, Mahesh. Mohan, can you share your screen? Arey buddy, you made a mistake. If it is greater than, uh, just a second. Lower is equals to mid plus 1. And what's the error? Error index of bound, index 2 out of bound for length 2. At line number 11, find peak element. Okay. Uh, Sir, the higher pointer will be at the will be your last index. It's not n, it's n minus 1. Make sense? Your higher pointer will be at the last index of your array, and it is not n, it is n minus 1. Fine? Yeah. Right? Write n minus 1 there and remove this condition. It's not needed. If n is equals to from line number 6 to line number 8, remove this condition. It's not needed. Oh, yeah, that's fine. That's fine. Submit it. Submit it. Yeah. How much time it's taking? That's 0 milliseconds. Okay. Fine. Yeah, am I clear with that? Yeah, you're welcome. Anyone else who is done with the solution? ऋत्विक, शिखा, anyone? आयुष, अर्नव, किसी का हुआ? आकाश. अच्छा, how many of you wants me to write the code? Raise your hand. Mm-hmm. Show me your code. What you are doing now, what you are doing, you're just assigning the values as soon as you got this thing that the previous one is the less than the next one. And you are just replacing the value with that the next peak element. That's it. Fine. So what would be the time complexity of this approach? And what we have written just now? This approach is fine. It will be submitted because it's an easy level problem. Fine. So you're not bounded with that constraints. Fine. But in the question itself, it's written there. You'll have to write an algorithm in big of log and time complexity. Fine. So this is a brute force approach, and it won't be taking much time because you're not comparing every other element with that. But you're going till the end of your array. It's still big of n. Fine. Approach is fine. Approach is fine. Akash, right? Akash, the approach is fine. But you'll have to follow the description part. Fine. Yeah. Stop sharing. Stop sharing. Anyone else who's done with the solution? Mahesh, Ayush, Arnav, anyone else? Say me yes or no, yaar, so that I can start with the solution. How many of you want me to write the code? Please raise your hand. Okay, I'm writing the code for you. So the first thing which I'll be doing, I'll be following the basic approach of binary search. I'll be having a low pointer which will be initially at zeroth index. I'll be having a high pointer which will be at the last index of my array. There will be a while loop, and in that while loop, I'll be writing a condition that my low pointer should be less than high pointer, a middle variable which will store the middle index every time. That will be low plus high by 2 if nums of mid is less than nums of mid plus 1. In that case, I'll be moving in the right part of my array. Otherwise, I'll be moving in the left part of my array by keeping mid as my track. And at last, when the whole condition will get break, when the whole logic will get failed, the low pointer will be giving me my answer. Run it. I have fine submitted. Fine, it's taking 0 milliseconds and reads 100% of the solution. Fine. So if there is any issue, please ask. Take 1 minute and see the code. And if there is any sort of issues with the code, please ask. I'm zooming in. So yeah, sure. Take 2 minutes and read this code and tell me what sort of issues you are having. I'm sharing two questions in the chat box. Fine. I don't want you to write the code just now. I don't want to explain you the logic just now. I just want to see that you guys are able to explain me the description of that question or not. Fine. So give me a moment. That's it. So take these three questions as your homework. Fine. So I'm not expecting that you will be able to solve all of the problems, but try to debug it. Try to go with the description part of this question. All these three questions are from binary search, and you have to decide that why we are using binary search in this question. Fine. So as like we have just discussed, I have so this whole these questions follows the pattern of binary search, and I have just discussed that is if there is something which where you have to search anything, and it's been written that you have to write an algorithm in big of log n time complexity, you will gonna use binary search in this case. Or if a sorted array has been given to you, you will always think about that can we use binary search in this question. Fine. So you have to follow this particular thing, that why we are using binary search in these three questions. Fine. So take it as a homework. And is there anything which you want to ask? Please ask. किसी को कुछ पूछना है? आकाश, ऋत्विक, anything? Okay, fine. Please copy these three questions. Fine. Take it as a homework. Uh, or I'll do one thing. I'll paste these three questions in that dog also. Fine.